Hey guys, welcome to our next lesson, and today we'll be looking at Kirchhoff's law. Right? So Kirchhoff's law is based on circuits, so analyzing circuits. So Kirchhoff's had two laws, right? So the first law is known as your junction rule. Second law is known as your loop rule, right? So the junction rule is sometimes called the conservation of charge rule from Kirchhoff, which states the total current going into a junction is equal to the current coming out, right? And your loop rule is sometimes referred to as your conservation of energy law, which states that the voltage change in a loop around a circuit is always equal to zero, right? So we have identified some new terms here that we need to distinguish. So exactly what is a junction, what is a loop, right? So let's look at that circuit there. So you should know that this circuit is a parallel and a series circuit, right? Together we have a battery. We have three resistors, R1, R2, and R3, right? So let's first define what a junction is. So a junction is the point in a circuit where current, when it reaches that point, it has to split, right? So when current reaches a point, it's going to split between wires. So some travels one way, the other travels the next way, right? So if we look, we have I1 being produced by the battery here. So it going through R1, right? When it reaches right this point there, you notice what's going to happen? It's going to split, right? So at this point here, I1 will split. So we have a portion of I1 going down here and a portion going right there, right? So we can call this, since this is R2, can call this I2, this is R3, we can call this I3, right? So the junction is at this point because when I1 reaches here, it splits into I2 and I3. So from that, we can get an equation for this circuit to be that I1, which is going into the junction, is equal to what's coming out, which is 2 and 3. So this would be your junction rule for this circuit, right? So let's look at the loop rule now, right? So the loop. So a loop is basically, we start from the battery or the source of the energy, right? And it's a one path from battery back to battery, right? So we're taking one path from one battery to around and it meets back to the battery, right? So let's look. So if we go from the battery here to R1, R2, and we come back to the battery, we can call that loop 1, right? We also have another loop, which be from the battery, it goes through R1, goes through R3, and then back to the battery. That's loop 2, right? So we see that the loops are just the pathway of current from one side of the battery meet back to the next side of the battery, right? So we have one loop here and we have an external loop there, right? So now let's generate an equation for our loop, right? But before we look at the loop, right, we need to note that the voltage is negative through resistors when the loop and current directions are the same. So that's very important, right? So once your loop direction that you're using and your current direction is the same, then the voltage in that resistor is going to be negative. So let's look. So let's go to loop 1. Right? And we're starting from the battery. We're going to call the battery epsilon, right? So the epsilon there means EMF, the voltage supplied by the battery. right? So to find what the charge or what's the sign of the voltage from your battery is we use these lines on it, right? So remember the long lines mean positive side, the smaller one means the negative side. So if we look at loop 1, it leaves from the positive, it goes through the and comes through the negative. So that means we're starting from a positive sign, right? So we have a positive epsilon, right? And then the loop goes through R1 in that way, and we notice I current, I1 is going, both direction is going that way, right? So because they're going in the same direction, then it's a negative. So it's negative V1, right? And then it's coming down, so I2 is going down, and the loop is going down through. So both of them, same direction. So negative V2, right? And then it comes back here, there's no resistor or anything there. So now that's equal to 0, right? So we can replace I1 and V1 because remember from Ohm's law, V equals IR, right? So loop 1 is positive EMF of the battery minus V1, which is I, going through R1 is I1, and the resistance is R1, right? Minus going through V2 is I2, R2 equal 0. So that's our loop 1. Next, we look at loop 2. Right? So again, our loop is going in this direction. So that means it's leaving our positive side of the battery. Right? Then it goes through R1, that direction. I1 is going that direction. So same thing again. So it's V1. Right? Now it passes here. R1 is I3 now is going that direction. Right? And our loop still going that direction, same direction. Negative V3, that's equal 0 because there is no other resistor here, right? So again we replace these, so it becomes positive epsilon minus I1 going through R1 minus I3 going through R3, and all this equals 0. Alright guys, so this is just an introduction to Coulomb's law because everything here will be about calculations, right? So our next lesson will be about using these rules to actually get some unknown quantities using Kirchhoff's loop and junction rule. Alright guys, so please ensure you understand this before we move on to the next lesson. Alright, so thank you very much and see you guys next time.